In this module, you will learn about the abridged life tables, its columns, assumptions involved, its uses, and also how to construct an abridged life table from age-specific death rates that are given. Studies are also given to show how these life tables have been used, such as to study early life disparity in particular periods of time in India based on data from the sample registration system for specific periods of time, that is between 1970 to 1975 and 2006 to 2010, in order to understand the consequences of death at a young age. These life tables are also used as a statistical tool by actuaries, demographers, and public health workers in order to know the mortality situation of a particular area for their purposes.
I am Dr. C.P. Prakasham, retired professor from International Institute for Population Sciences, Mumbai. I will be teaching about the methods of construction of abridged life table, module number 27. Learning objective: construction of abridged life table, columns of life table, assumptions involved, illustration, selected features of life table, uses of life table. In these are the life table columns for the abridged life table. Age interval is in x to x plus n. NQX, probability of dying in the age interval x and x plus n for those alive at the beginning of the interval. LX, number of survivors alive at age x, that is radix. NDX, number of deaths between age x, x plus 1. NLX, number of person years lived between age x and x plus n. Capital TX, total number of person years lived after age x. EX, life expectancy at age x. Illustration of construction of abridged life table from age-specific death rates, ASDR. Step 1. Estimation of ASDR is n capital MX equals to n dx divided by npx. That is, number of deaths in the x to x plus n age interval divided by population in that age interval x to x plus n. As an illustration, age interval is given 0 to 1, 1 to 4, 5 to 9, up to 85. Population by age group is given, and then number of deaths by age group is also given. We can calculate age specific death rates, and the last column, that the death rates is given by the deaths of each age group divided by population is given in the column n capital MX. Step number 2 and 3, estimation of probability of death. Step 2, this NMX given in the above table, which is taken as central age specific death rate or life table death rate, LTDR, as small nmx, column number 4. Step 3, from nmx the probability of deaths nqx is estimated. The relationship as nqx is equal to 2 small n multiplied by nmx divided by 2 plus n into nmx. Step 3, column number 3 is calculated for the age group 0 to 1 as 2 multiplied by 1 multiplied by 0.018309 divided by 2 plus 1 multiplied by 0.018309 equals to 0.01814. For the age groups 1 to 4, then n equals to 4, and other age group 5 to 9, 10 to 14, and so on, n equals to 5. For the last age group 85 plus, n equals to 5 considered, assuming that all will die after crossing 85 years in the life table. Step 4. A hypothetical birth cohort of size small L naught equals to 100,000 is considered, which is subjected to experience the mortality conditions exist in NQX values given in the column number 3. Estimated number of survivors at the exact age by the formula Lx plus n equals to small lx multiplied by 1 minus NQX. L naught equals to 100,000, which is radix. Small l 1 to 4 equals to 100,000 into 1 minus 0.01814 equals to 98186. Similarly, L 5 to 9 equals to 98186 multiplied by 1 minus 0.00322 equals to 97870, and so on up to 85 plus. Step 5. Estimate the number of deaths in the life table NDX, that is column number 5. NDX is equal to Lx minus Lx plus n, that is 0 D1 equals to 100,000 multiplied by 98186 equals to 1814. Similarly, 1 dx equals to 98186 minus 97870 equals to 316. Last column 85 plus is small l 85 plus equals to d 85 plus, because all will die at this age. Column 6. Estimation of n capital X values, which gives the person years lived or life table population in the age group x to x plus n, is derived as n capital Lx equals to n by 2 small lx plus small lx plus n, and L naught equals to alpha into L naught plus 1 minus alpha L1, where alpha is estimated. This is the estimation of alpha is different from abridged life table to the current life table. For abridged life table, alpha is equals to 0.3, hence column 6 is derived as capital L naught equals to 0.3 small l naught plus 0.7 L1 equals to 0.3 multiplied by 100,000 plus 0.7 multiplied by 98186 equals to 98730. For capital L1 equals to 1.9 small l1 plus 2.1 small l5 equals to 1.9 98186 plus 2.1 multiplied by 97870 equals to 392079. N capital Lx equals to n by 2 into small lx plus lx plus n. For the last age group, open-ended age group, here 85 plus is given as capital L85 equals to small l85 divided by infinity capital M85 equals to 23595 divided by 0.157564 equals to 149749. Column 7 and 8. Estimate Tx, number of years lived after each age. Tx equals to Tx plus 1 plus capital Lx. Cumulation of n capital Lx from down to top. T85 plus equals to 149749. 80 T85 equals to 149749 plus 154935 equals to 304684, and so on. 0 T1 equals to 7092423 plus 98730 equals to 7191153. Column 8 is expectation of life at age x equals to E naught x. E naught x equals to Tx divided by small lx, and E naught x is the expectancy at birth. Hence, E naught naught equals to 7191153 divided by 100,000 equals to 71.91. E naught 14 equals to 6211456 divided by 97685 equals to 63.59. Life expectancy. A graph is drawn between age interval and life expectancy estimated from the abridged life table given above. A graph shows that life expectancy was 71.91 years at birth, increased to 72.23 at age 1 to 4 and slowly declined, and 7.94 at 80 to 84 years. That is, in a hypothetical cohort, person survives up to 80 years, she likely to live 7.94 years hence. Survival ratios. Survival ratios can be derived from the life table. N S x x plus n equals to n capital X plus n divided by n capital Lx. Survival ratios derived from life table used in population projections and explained in population projections module. Abridged life table. Studies have shown measuring early life table disparity in India. A study on early life table disparity in India using complete life table for the period 1970-75 to 2006-2010 were constructed from abridged life table and death rates provided by the Sample Registration System SRS in India. The data was used to understand the consequences of death at a younger age. Selected features of the life table. We will examine some features of the constructed life table that are relevant to the interpretation of life table. Number 1. Sum of the values in column 5 will be equal to 100,000, that is equals to small l naught. Number 2. Sum of the values in the column 5 from a specific age will be equal to the values at this age as shown in column 4. For example, L30 equals to 5D34 plus infinity D35. 95523 equals to 765 plus 94757. Hence, small lx as cumulative small lx number of deaths after a specific age. Age pattern of death. Number 3. Age at which people in the life table cohort die will give age pattern of death. The column 5 of the life table NDX gives the frequency distribution of the age at death in the population. A graph of NDX across the lifespan is given in figure 1 will show the frequency distribution of the age at death in the population. A graph of NQX across the lifespan is given in figure 2 will show the probability of dying in the age interval x and x plus n of those alive at the beginning of the interval. Age pattern of probability of death across lifespan. Number 4. The small lx column also has a probability interpretation. Lx by L naught is the proportion of the newborn surviving to that age. These proportions are called survival probabilities. A plot of the survival probabilities across the lifespan is given in figure number 3. Number 5. Number of persons dying before a specified age x is the sum of deaths from the beginning of the table to that specified age. Number dying before age x equals to summation of h equals to 0 to x minus n, ndh equals to L naught minus Lx. Example, the number of persons dying before age 10, 1d naught plus 4d1 plus 5d5 equals to 1814 plus 316 plus 184 equals to 2314.54 equals to 2315. L0 minus L10 equals to 100,000 minus 97685 equals to 2115. Number 6. From 5 above, the proportion, the probability that a newborn will die before reaching age X is calculated as L0 minus Lx divided by Lx equals to 1 minus Lx by L0. Example, the probability of dying before reaching age 10 equals to 100,000 minus 97685 divided by 100,000 equals to 2315 divided by 10,000 equals to 0.02315. Life table birth rate LTBR equals to total number of births divided by total population equals to L0 by T0 equals to 1 by E0. Use of life table. Life table is statistical tool used by actuaries, demographers, public health workers to present the mortality situation of a country or area. To know the probability of man or woman aged 40 years will survive to his her age at 70 years. How many years a baby born likely to live from the life table calculation. Life table birth rate following life table mortality pattern. Questions. Here you are required to answer the questions by looking at this module. What do you understand the word life table? How many types of life tables can be constructed? Describe. Explain the columns of abridged life table. Explain the assumptions involved in construction of life table. Fill up the blanks. Here it is given some questions you have to fill up by using the modules which is given here. Thank you very much.